Hello, everyone. Again, this is my period 4. Rebecca, I just caught her attention. Wave to the camera, Rebecca. Hello, how are you? Jack's back there working hard. Excellent. You look very awake this morning. Excellent. Excellent. Warwick is here. He was doing some extra credit last night. I'm hopefully he got some sleep. Everyone's here. John is actually working. Okay. My shout out to John's mom. Very nice talk we had. Wonderful son. Okay, I have to say that I'm on film. Okay. No, I'm kidding, of course. Lana's here, good. Shakira, everyone's here, excellent. So let's begin. Now, what we're going to do is we're going to look at a clothesline problem where the LS is very short. Okay? So what I want to do first is I want to see how is this changing? How is that changing, that T? This is actually T. That's actually the tension in the rope. Let me write that a little clearer. Okay? Let me write that a little clearer. So this is actually T. Okay? Let me write that a little clearer. Okay? All right? So if we look at T, we know that cosine theta equals what? My camera person is here, Lana. Excellent. Great smile. Is going to be, that's the angle there. That's theta. Okay?
25 times cosine theta.
So it's going to be adjacent, okay, 25 over, we'll call this FT, shall we? We'll call this FT. We'll call it FT. That's a little better, don't you think, Lana? FT. Okay. FT. Okay. So if that's the case, okay, if that's the case, then FT is going to equal 25 over cosine theta. So FT is going to equal 25 over cosine theta. And that's what that is. Okay? So this is what I want to do. I have these numbers written down here. And what I'm going to do is get your calculators out, and I want to know what cosine of each one of these angles is. Cosine of 30, cosine of 45, and cosine of 80, 60, 80, and then cosine of 89.999. Nika's looking at me like I'm crazy talking to myself, okay? So what do I got? Anything? What do I got for the first one? Cosine of 30.
Okay.
Cosine of 30.
So
Go cosine of 30.
do we have the angle?
Yeah, cosine of 30. That's the angle.
Oh, my bad.
That's okay.
30.
I know the answer, but we'll see if she does.
0.86.
Excellent. 0.866. Very good. 0.866. Okay. What is the cosine of 45?
0.71.
0.707. You know how I remember that? There was an airplane that, when I was a kid, one of the first big airplanes, was very long, tubular. It was called a 707 as opposed to the 747, 727, 707. I don't think they even exist anymore. But that's how I remember that, 707. So it's going to be 0.707. Okay, and then what is cosine of 60?
0.5.
That's 0.5. And then cosine of 80 is what?
Is 0.17.
0.175. All right, let me write that. Let me write that a little differently. Okay, that's going to be 0.173.
Yes.
Okay, and then now this is a tough one. This is a tough one. Be patient with this. This is going to be a really, really, really small number. You see how the numbers are getting progressively smaller? See that? What do you got? Point. So let's do this in another color altogether. Let's do it in black, okay, shall we? So this is going to be 0.
I got scientific notation.
Yeah, but take it out of scientific notation.
So.
What do you got in scientific notation?
1.74 times 10 to the negative 5th.
Times 10 to the negative 5. Pretty small, don't you think?
So we got to move the decimal point.
So we got to move it over. So we're going to say 0.0000174. See if that works. 1, 2, 3, 4, 5.
Yeah.
Cool?
Yeah.
We're there? Excellent. So you can see that what's happening here? What's happening here? Let me erase some things here. Let me erase this. I'm going to erase this, okay? Right? Now, what's happening? As theta
Increases.
approaches 90 degrees, what happens? Cosine theta
Gets closer to 0.
approaches 0. You see that so far? Are you with me?
Yes.
Okay, now, let's do this. Now, 25 divided by this, and this. Okay, so what's 25 divided by 0.866? Let's use a color. I'm really into different colors here. Okay, we'll use green.
28.8.
Okay? I'm half Irish, okay? What is it?
28.8.
28.8. And this is newtons, right?
Yes.
Okay. Now what's next?
25 divided by
0.707.
707, and that equals 35.
35 even?
0.36.
35.4. That's cool. We're cool. 3 centimeter figures is good. Right? I'm going to take a drink of coffee. Excuse me. Oh, coffee in the morning. Bliss. Okay. This one's easy. That's going to be 50. Okay. Just a word of warning here. When the angle between LS and FT equals 60, then the tension in the line equals the load. Got it? You got that? Sure? Excellent. See what I mean by that? There's the load, 50.
Yes.
FT here is 50. Okay? When this angle here is 60, the angle in the FT equals the load. Okay? Now, what is divided by 0.173, 1400 or?
144.5.
144.
0.5.
144? I don't think, is that right? Are you sure?
Yes. Take a look here.
144, we have a, let's see. Okay, 144.5, right, 25 divided by cosine 80, close parentheses, and 140 cosine 80, right?
Yeah.
I get something different. Right, cosine 80, right? 0.173, that's right. Okay, what am I doing? So then 25 divided by 0.173 equals 144.5. That's exactly what you said. So we'll say can we say 145? Is that all right? Okay, 145. Okay, 145. All right, now, so you can see how it's getting larger, right? And it's almost doing it like amazing. Wait till you see this, 89.999. So that's like almost 90 degrees. That's really close to 90 degrees. See, as it approaches 90, that's going to approach 0. Okay, it'll never get there, but it'll approach. Okay, so what do we got? Big number. Excuse me while I fill this in. Yes, what do we got?
1,436,781 Newton.
Point anything? We don't need any point.
0.6.
First of all, to have 7 centimeter figures is a little suspicious. So